Hello students. Today we're going to be taking a look at our chapter review for the chapter 14 test. I've already done the problems, so I'm just going to go ahead and walk you guys through via, just kind of pointing out the steps that I've already performed for you. The screencast is a little bit different than the ones I've done in the past, but just to try to mix it up a little bit, we'll see how this goes. So number one, refer to the figure at the right. If the measure of arc FH is equal to 68 degrees, find the measure of angle FGH. So 68 degrees here, that is an arc, and the inscribed angle, which we already remember hopefully from the prior sections, that it happens to be half as big as the angle, the arc. So the inscribed angle, again, half the size of the arc of 68, half of 68, simply 34. So A. Number two, in circle B at the right, the measure of angle EAC is equal to 4x, and the measure of angle EDC is 2x plus 18. Find the value of x. So in this particular picture, you can see I've already marked up arc EC in green. Now that's just to kind of highlight the fact that angle EDC but also EAC must be congruent, because if you notice, the arc is essentially created by both of those respective inscribed angles. This is another theorem that we've learned in the past. So I've marked up this angle congruent to that angle, both in red, as you can see. And again, thanks to the theorem, the arc suggests that these two inscribed angles are congruent. And therefore, 2x plus 18 I can set equal to 4x. And the math is pretty straightforward. I subtract 2x, therefore 2x equals 18 divided by 2, so x is equal to 9. B. Number 3, in circle N at the right, ST is a diameter. Find the value of x. Okay, because ST is a diameter, and also because you note here that we've got a triangle, anytime there is a triangle inside of a circle of which all the endpoints touch the circle, and in one instance, one of the sides, particularly the diameter, as we can see designated with ST, that happens to be also the hypotenuse of a right triangle. It's always the case where if that's the diameter, one side of which is the diameter, you have a right triangle. So the right angle I've marked here as SRT. Therefore, because angle, we'll just call it S, and angle T happen to add up to the 90-degree angle to equal 180 in total, I could do the math subtracting 90, or I could just add 4x minus 15 plus 5x plus 15 and set it equal to 90, and that's what I did. It ends up that the 15 and negative 15 cancel. Add 4x and 5x to get 9x, divide by 9 to get 10, so B. Number 4, and then 5 as well, two interesting statements to designate whether or not it's true. We fill in the blank to make it true. An angle is inscribed, or an inscribed angle, if and only if, so it goes in two directions, if its vertex lies on the circle and its sides contain blank of the circle. Well, the blank here must be chords, and the reason it's chords, gosh, if you look at number 1, that's a very nice kind of depiction of an inscribed angle, angle G, right, as we saw in number 1. And as this particular point is clearly designated on the circle, its vertex is on the circle of that angle. We can also note that the sides of the angle, GF and GH, must be chords. And again, chords are just segments that have its endpoints on the circle. So the answer, D. Number 5, in a plane, a line is a tangent to a circle if and only if it intersects the circle in exactly blank point or points. Well, a tangent line will always intersect a circle at one point. It can never intersect at more than one. It's the very definition of a tangent. So letter A. We'll also look at a question, I'm certain here later, in which we're going to see tangents and angles respectively kind of take shape. Let's move on. 4, questions 6 and 7 refer to the figure at the right. In the figure, BC is tangent to circle P at point D. BA is also a tangent to circle P. All right, so speaking of tangents again, here's BA. That's a tangent. As you can see, it touches the circle at only one point. And here's another tangent, BC. Again, that touches the circle only at point D. Now, what I've done, speaking of tangents, but now specifically at the point of tangency, we have a what? Intersection of which is a 90-degree relationship. The intersection, particularly of the radius of the circle and the tangent, are always going to create a 90-degree angle. And that doesn't just happen here. It also happens here and here. So at point D, we also have a 90-degree pair of angles, two 90-degree angles. So what does that mean then? For number 6, to find CP, which is this segment right here, okay, CP just so happens to be a side of this triangle, which particularly you can see here, of course, is a right triangle. And as we remember from prior chapters, actually, we've got the Pythagorean theorem to take into account. Because it's a right triangle, in other words, if it's a right triangle, then a squared plus b squared equals c squared. So I did that here, 10 squared plus 24 squared equals CP squared, CP being the hypotenuse. I added these two, took the square root of both sides of that respective equation, and I ended up with simply 26, which is letter C. Find the value of x. So in this particular picture, again, we've got a side of AB, but also a side of BD. Now, I'll call it a side only in the sense that it is, well, this is a side of a triangle, but this isn't really designated as a side of a triangle. But if we were to draw another segment here, BP, maybe you could isolate that as such. I won't go that route necessarily because I don't have to, although there's a nice proof of that to designate the tangent relationship of which the two tangents intersect at a point outside the circle. Instead, the theorem that simply needs to be applied here in context is just equating 4x minus 3 to 21. Because these are two tangents that intersect outside of a circle, you can simply equate the two. They are equal to each other, or congruent. I set them equal, as you can see. I added 3 to both sides, and if you divide by 4, you get simply C, or x equals 6. Okay, so let's take a look at number 8. So number 8, this one is, let's see, find the measure of angle WSK in the figure at the right. WSK is interior to the circle. It has 2 arcs of which 35 degrees and 135 can be added together thanks to the theorem, if you recall, adding the two chords, or excuse me, arcs, thanks to the chords that intersect. The arcs can be added together and divided by 2, which is what I did to get 85 degrees, letter C. Moving on to number 9. Number 9, this one in particular asks for the measure of angle C, which is exterior to the circle thanks to the secant and secant intersecting. I have an arc of 13 and an arc of 65, the theorem of which can be applied as 1/2 the difference of 65 and 13. And that ends up being 26 degrees, so letter A. Moving on, number 10. This one in particular has, let's see, it's got a circle with another chord intersecting. They do give you the angle inside the circle of 92 degrees. So the math that I set up is 92 equals half of this arc, 3x plus or minus 9, excuse me, plus 5x plus 9. Minus 9 and plus 9, of course, cancel. I multiplied both sides by 2, which ended up here with 184 equals what? 5x plus 3x, which is 8x. Divide by 8 to get x equals 23. Now remember, the answer is not specific to x. It is supposed to be specific to arc FG, which I did off to the left here in green. So 3 times what I just got for x, 23 minus 9, that ends up being 60. So letter B. Moving on, number 11. In the figure at the right, CR is tangent to circle T. I did mark up the point T there in the middle because they didn't have it there. Find the measure of angle R. So we want the tangent and secant intersection. In this case, because we know 72 degrees as one arc, we know 210 as another. The math that I can perform here is simply taking 210 minus 72 and dividing that by 2 to get letter B, which I did right there. I'm going to go ahead and continue. and if I don't complete all of the remaining questions, I'll complete them in an audio recording. So here we go. On the next page, you can see here on number 12, let's go ahead and scroll down. On number 12, it says in the figure at the right, AK and AT are both tangents to the circle. Find the angle A that's exterior here. So these two tangents, as we again kind of reminded ourselves on the prior page, are in fact congruent. So that's a neat relationship to kind of connect to. On this particular question, though, because they're asking you to find the measure of angle A, we're going to go ahead and simply take 1/2 the difference of this arc, which we do still have to calculate, and I can do that by taking 360, which is the full arc value of the circle, 360 minus 122, which we do know there, therefore what, 238. I then, in this particular equation again, can say half of 238 minus 122, and that then leads to 58 degrees, letter A. Number 13, in the figure at the right, BA is tangent to circle P. Find the measure of angle ABC. So BA, there is your tangent. This arc is known as 118. The simple theorem to apply here is taking 118 divided by 2 to get this particular angle. And that, of course, simply is letter B, 59 degrees. Number 14, find the value of x in the figure shown. This is a chord situation, but not angles, but actual values of parts of the chord, in this case x. So the simple math is 8 times x equals 5 times 4, so 8x equals 20, divide by 8, and x is 2.5, so letter A. Number 15, find the value of x in the figure shown at the right, so same type of situation. You've got 10 times x, chord, and the parts of those chords respectively, equals 5 times 6, so 30. 10x equals 30, we'll divide both sides by 10 and end up with 3, so letter B. Number 16, refer to the figure shown at the right. Find AV and RV, if necessary, round to the nearest tenth. This is a secant situation in which you have an external secant segment here of 6 and here of 4. The full secant here, AC, is 11, and the full secant here, AV, is x plus 4. So the theorem applies as follows. The external secant segment of 4 times the secant x plus 4 is equal to the other external secant segment of 6 times 11. Okay, so we'll do the math. What I actually did here is multiplied 6 times 11 and I divided by 4. So 66 divided by 4 is 16.5. I subtracted 4, and therefore x is simply 12.5. When I get x, I can plug it in to find what? 12.5 plus 4 to get this full secant AV to be 16.5. So the answer must be what? D, which is the first part 16.5 and the second part 12.5, which speaks to RV, letter D. Number 17, refer to the figure shown at the right, find the value of x to the nearest tenth. This is a tangent secant situation. We don't know the tangent value, but we do know the secant in full as well as its respective parts, inside and outside the circle. 11 plus 7, of course, is 18. I've got 7, which is the external secant segment. I've got 18, which is the full secant. And then I can equate that, the product of which equated to x squared, right? The tangent squared, if you remember. If you do 7 times 18 and take the square root of both sides of that equation, you end up with 11.2, roughly speaking. And the answer, therefore, is letter C. Moving on, these last 3 questions here. Let's take a look. So number 18, write an equation of the circle with center at the origin and radius of 12. The origin is simply 0, 0. So letter D is the only answer that makes sense. X minus 0 quantity squared plus Y minus K quantity squared. And of course, 12 squared is 144. Number 19, the center is negative 3, 4 with a radius of 4. Letter C is the only answer that makes sense on this problem. Negative 3 leads to X plus 3 and positive 4 leads to Y minus 4. Both quantities squared, of course, and then 4 squared, which is 16. Last but not least, number 20, this is your equation. So negative 5, 9, and 5 squared, which is 25. So letter B speaks to the center, but also the radius of 5.